Okay, as promised just now, okay, I've corrected the mistake I made in example 6.3.2, okay, part C. Okay, so as I mentioned just now, if we want to find the probability given balance equals to this and student it's a student. Okay, so using Bayesian theorem can be written as something like this. So the x is actually something unknown, so I just call them dot dot dot. Okay, so using Bayesian theorem and naive Bayes, the top here can be actually decomposed, so the final value is going to be something like this. Down here, as I mentioned before, we need to actually calculate both the condition given default to be yes and no, okay, in order to estimate, okay, the value. So that's why we actually need to find this thing. Okay, so the student yes given default no is actually 0, and therefore we are able to find that it's actually 100%. Okay, so anyway, this thing we'll see again in the example. Okay, now we'll proceed to the next example, example 6.3.3. okay, I will upload the part of the answer, okay, to my Google site slightly later. Okay, so first part is to state the assumption used in naive Bayes. I've mentioned many times, right? Okay, it's actually assuming that x1 until xp are independent. Okay, so I will write it down. Okay, for the second part, to make things the presentation shorter, I've defined some of the data, okay, and program. So here it goes, example 6.3.3. Okay, so in order to perform calculation, we need to look at the table, right? Okay, so what are the given values? So I have actually so the given is whether a Malay female customer, age 29, of income 7,800 will buy the product or not. So condition is actually over here. Okay, so let's turn to the table to perform the estimation. Okay, there's no highlight here. I've create a table with highlight. Okay, so you can see that there are 6 buying according to the data and 4 not buying. Okay, anyway, the whole of this table is entered into R. Okay, so I just run it in R. Okay, so if I just look at it, okay, so you can see I just denote not buying as just not. Okay, and I denote M for male and F for female. Okay, others I think are more or less fine. Okay, so now let's perform some estimation, right? Okay, if we use the naive Bayes model, we can basically, okay, it will actually estimate all the parameters for us. Okay, so want to show you the 4 values. So let's have a look at the values. Okay, here are the values. So this is the formula, right? Okay, so we have without any Laplace schooling. So buying or not, okay, from the table we can actually see there are 10 data. Okay, we already saw that there are. Okay, just to flip to the Okay, so 10 data, 6 will buy, 4 will not buy. So this is actually reflected over here, buy and not buy. Okay, then next is this kind of data. Okay, so how do we actually estimate all this? It's all based on values here. Okay, so I'll create a terminal. Okay, and then let's run the R. Okay, so for age, right? So okay, under buying, okay, according to the table, these are the corresponding values. Okay, so all these are obtained from from this part. Okay, so you can see 22, 30, 26, 27, 50, and 31. Okay, so others are similar. You can just refer back to the table yourself. Okay, so how do we estimate it? So we can use mean to actually find it. Okay, that's how 31 is obtained for the buy. Okay, and similarly for standard deviation, right? Okay, so it's exactly the same thing. Okay, and then so okay, now race. So for buying, right? Okay, buying. If it's Malay, it's 1/3, right? Which is equivalent to 2/6. Okay. If it's female, okay, look at the gender. Female is okay 4/6, which is equivalent to 2/3, right? Okay, so no issue. Okay, and finally the income. So the income is going to be mean income 7,500, which is shown here, as well as the standard deviation, right? Which is this value. Okay, which is standard deviation for buying. Okay, because we want to check whether it's a buying or not buying. Okay, therefore we also need to go through all the steps again for the not case. Okay, so that would correspond to all these, right? Okay, sorry, this one should change to not, right? Okay, so all these are the, okay, given the case when it's not buying, what's the probability of having all these values? So let's look at it again. So the race tells us that for Malay is 1/4, isn't it? Okay. For gender, female of not buying is again 1/4 shown here. Okay, others, okay, all these numericals values again from the table, and okay, I'm not going to go through the calculation already because we have verified for age and income just now for the case when it's buying. So this is basically the same. Okay, so after we have keyed all these things, what do? We want to find the probability, right? Okay, so what is the posterior probability of buying? Okay, so kind of estimate is going to be buying is going to be the condition given, right? So it's going to be this amount times this amount. Okay, and then so we need to find out what is the probability density value for H when buying. So this is going to be, so the formula, as I have seen many times, is 1 over square root of 2 times pi, then times SH, right? Okay, because now we are checking the H case. So SH is equals to integration of H pi. Okay, multiply with the exponential function of 0.5. Okay, so it's x. What is x? X is the H, right? The H is given here. Just look at it, 39. So that's why here we have 39. Multiply with the mean of H. So it's H5 minus the mean of the H. And then square it. Okay, over 2 and over the H square. I think that correct. Okay, so I mean similarly for income. Okay, I'll just put income. This is the abbreviation instead of being too long. This one is income. Okay, for income, the given value is actually 7,800. So 7,800, and then this also income. So these are income. Let's just change income. Okay, so I think we are able to estimate them by now. Let's go ahead and check. Okay, no error. So what is the probability of buying? Okay, probability buy. Okay, I haven't actually seen all these values that here. I call so